Hi.
Hi.
So, my friend Erin Frank, we met a long time ago. Actually, we first met in what 2009, I think. Did we decide 8 or 9?
Yeah. No, actually, it would have been 2007 is when I moved to New York.
Oh, well, that would be it then.
Yeah.
So, Erin and I were working in the same studio together. I was teaching, and she was desking and laundering and all the things, mopping. Were you still wiping the mirrors with newspaper at that point?
Oh, I think we transitioned while I was
so
there.
Weird. Yeah. Anyway.
And we went from up and down to circular, all the things.
Really important. Newspaper.
Yes.
And when I was trying to determine whether I was going to move to Austin, I reached out to Erin on Facebook. Hadn't seen her in years, and I was just like, I don't know if you remember me. I used to teach. And she's like, of course I remember you. And so she insisted that I stay with her while I was here for the weekend visiting, and she and I stayed up, like, sitting around her kitchen table till 2 a.m. every night, just chatting. And now
we had my pelvis model out.
Yeah.
Inspecting Patty the pelvis.
Patty the pelvis, amazing. And one of the reasons I did decide on Austin as my new home was because of my Miss Erin Frank. So thank you for that. And I believe you were not drinking either because you were doing a dry January. So we were still up till 2 a.m. chatting our heads off, even without our reduced inhibitions. Anyway, so when I was mentioning my friend who just sliced her finger and whose tendon retracted down into her palm, this is the friend. So tell me a little bit about, I was talking, and I misspoke. I was saying when I was recording that you slice your flexor digitorum superficialis. I got it confused. It was actually flexor digitorum profundus. But this is a good teaching moment because we have the different joints in the hand. We have the proximal interphalangeal joints and the distal interphalangeal joints. So and I just got the two muscles confused. I was thinking that flexor digitorum superficialis extended beyond both of those joints into the end of the digit here, crossing over both the proximal and the distal interphalangeal joints, but I was mistaken. Flexor digitorum profundus is the one that crosses both joints. Flexor digitorum superficialis does in fact cross the MP joint, the metacarpal phalangeal joint, and does cross the proximal interphalangeal joint, but doesn't cross the distal. So flexor digitorum superficialis can't flex that. It's called dip, which is the distal interphalangeal joint, DIP. Doesn't cross the dip. So it doesn't have the capacity to do that. Anyway, I was speculating that because this tendon was also attached to 3 other branches, that it didn't retract further into the forearm. What do you think about that?
Yeah, I think that's a really interesting observation, and it kind of made me wish that I could remember being in a cadaver lab and seeing where exactly those branches initiate from its muscle belly, basically, because we all know that tendons connect muscles to bones.
We do all know that tendons connect muscles to bones.
As opposed to ligaments, which connect bones to bones. So if your tendon is kind of like this outgrowth of a muscle that attaches to the bone, and so you're right with respect to this one, it's one muscle that controls all of the digits. So where exactly though that tendon starts branching off into the separation of the phalanges is something I'm not too sure about. I was looking at this software that I have, Complete Anatomy, which is amazing, and I just went to go check that specific muscle, and from that software image, it looked like the tendons actually did start splitting off, like a little higher up in the forearm. But I don't know if that's just that software's model of it, and that might be also a variability amongst us as humans. Maybe your tendons start to branch off down here, whereas mine start to branch off in the hands.
But think about it. Even if they are, it's still one muscle belly. So even if they branch here, if I shorten that muscle, it's not going to pull. You know what I mean? It's still, they're all stuck to these.
Yeah, it's not
That's
going to
still
go all the
holding
way to
it.
its origin.
Yeah, exactly.
Yeah.
And I was mentioning that I thought perhaps flexor pollucis longus might be a better example of that, but you think that the origin is here in the thenar eminence, is that right?
Oh, no, you're right about
it is. So
the
it's in the forearm.
longest is in the forearm.
Cool.
There's a brevis that's in the hand, it's an intrinsic hand muscle, but you're right, the flexor pollicis longus is in the forearm. So yeah, that one is just one long tendon.
So do you think if you had sliced here instead, maybe it would have retracted even further?
Yeah, maybe.
Yeah.
And I also think about tendon sheaths as well, and how
true.
there's different zones of sheaths that wrap around the tendon, if that would help to kind of anchor it to the fascia that's surrounding it. But that makes total sense to me, how a singular muscle with that one tendon would be more likely to retract all the way in.
Yeah, and I hadn't even considered the sheaths. That's a whole other issue with what's that one called? Deputrans.
Oh my gosh, the special test. Caught me off guard with that one.
You know I'm always going to catch you off guard.
That's a good reminder. Look at special tests.
Yeah.
Yeah. But like what, an ulnar deviation?
What is it called? Tenosynovitis. That's what it's called.
Mm-hmm.
Yeah.
Yeah.
Did I catch you off guard with that one too?
Yes.
Yeah, okay. All right, cool.
I was just like you with the superficialis versus the profundus thing. So you were mentioning how initially one would think that the superficialis would go all the way to the most distal end based on the name of it, but it's actually with reference to the muscles belly themselves. So the FDP, the flexor digitorum profundus, is deeper than the FDS.
Got it.
This FDS's muscle belly is superficial to or on top of the profundus.
And I remember trying to remember it in school. I thought like more profound was thicker belly muscle, but really more profound is how far it extends. It has a more profound extension to the past the distal interphalangeal joint. So all of this is interesting context for the importance of understanding muscle insertion points and how they cross the joint, and determining what action a muscle is responsible for. If I truly was mistaken when I said that flexor pollicis longus did cross the wrist joint as well, it wouldn't have any impact.
I was just saying that, like, why do we care about these specific muscles in the hand? Most people aren't really worried about the sexiness or suppleness of their thenar eminence, right? I don't know.
Lovely thenar eminence.
So sexy.
So sexy.
I do know there are some, from research, there are some competitions on grip strength. One of them is like the Munster Bastard Backyard Bash, where they like open up jars and do stuff with their grip strength. But
Jeff, there's a jar opening competition somewhere. Go register.
There are a couple reasons why we can care about the intrinsic hand muscles and the muscles of our forearm that control our hand. And grip strength is something that's super important. You don't realize it until you lose it. But it's also an indicator for longevity. It's something that people test to see how long you have to live.
Interesting.
Like, can you get yourself up off the floor? But also, how is your grip strength? So that's interesting. But also, the muscles in your hand and your forearm, when they contract, they send signals to your bigger, sexier muscles of your biceps and your triceps. So whenever teachers reference the grip or your fingers together, it's not just for those specific muscles, but also to help you activate more the biceps and the triceps.
Muscle irradiation.
Yes, muscle irradiation. Do we already know about that?
No, we don't cover that in the topic in the course at all. So
for the advanced.
Yeah.
To be.
That's the advanced version.
Yes, advanced class.
Coming next.
Okay.
So it is possible that flexor pollicis longus could potentially retract into the forearm itself but that is an important distinction. Knowing the proximal attachment of flexor pollicis longus would help me to determine whether it could potentially retract into the forearm itself. Flexor pollicis brevis, Erin informed us, the attachment is here in the thenar eminence. So of course it wouldn't retract into the forearm. It doesn't even exist there. But knowing the difference between those two muscles can help us fully understand the muscle and all of the actions for which it's responsible.
Mm-hmm. Yeah. And that actually might be a good segue into talking about squeezing the butt and why teachers would say not to do that, and backbending and stuff like that.
Yeah. Thank you for that elegant segue. There are certain things, and I have several of them peppered throughout my course, things that I hear teachers say that aren't necessarily advised. And there are a couple of really common ones, even outside of the Bikram realm in the general vinyasa Western yoga world. And a couple of them that come to mind are tilt your tailbone. So you may hear that in class, and I think it was more prevalent several years ago, but then there was all this sort of backlash and online blog posts about why it's so bad to talk about why it's so bad to say tilt your tailbone. Also squeeze your butt. So do you have any insight on some of these sort of forbidden yoga instructions and those particular commands, and why?
Yes, so I have definitely been, I don't know if culprit is the right word, but one of those people to make those kind of statements before, black and white.
I think we all have, is the point.
Yeah.
Because we hear things and they seem to make sense to us, and then we roll with them. But as teachers, you have a very important role in either facilitating these things or kind of nipping them in the bud.
Yeah, and I really appreciate your emphasis on asking students and potential teachers and current teachers to go and critically think about what they hear and what they're saying. And in addition to that, being willing to alter what you believe to be true. So I know that I've definitely thought like, oh, well, I know I'm having this pain for sure because I'm over squeezing my butt. And it kept happening even though I was relaxing my butt as much as I could. And so I had to alter the story I was telling myself about that, and ended up getting rid of the pain by strengthening my butt muscles. So in addition to questioning what you hear from other people, I think it's also good to consistently question what you hold to be true, and you might have to change your beliefs on certain things with new information or new experiences. So I think that's a great thing that you emphasize in your course.
What do you think about squeezing the butt? So we know that contracting gluteus maximus and contracting piriformis, those are going to laterally rotate the hip joint. What do you think it is about squeezing the butt that was determined to be so off limits?
Well, from what I remember when that was the big hubbub on the internet.
There's always something.
There's always something. And it's interesting being around for a while, you see cycles from that
totally,
through.
absolutely.
It's like, oh yeah, it's like retro, it's like clothing. Like that was popular 7 years ago. Okay. But what I remember a lot from that whole don't squeeze the butt conversation was in reference to back bends and trying to take away the pain that maybe some students were feeling in their lower back while they were doing back bends. And the rationale, I think, was that if you don't contract your glutes, then you'll be forced to use more of your back muscles in your back bends.
Which is what we're going for in this instance.
I think it's relative, and that's a good point about when to say something like don't squeeze your butt when you're giving cues to people, and also when you're giving feedback to a teacher about their cues. I think that it's so important to look at the context,
of course,
right? So if you're asking someone to do a back bend, just the same way as if you're asking them to do a forward bend, a lot of times it's a composite movement. So it's not just the spine that we're looking at, but also the hips and the pelvis and the legs, right? So you know that when you do a forward bend, you could round your spine forward, or you could keep your spine at extension and hinge at the hips. They're both forward bend, but they're different, composite forward bend, but they're coming from different places. It's the same thing with your back bends. You can extend your spine and keep your hips flexed or extended or neutral, and vice versa, right? I think composite movements in back bends are great, especially for most of us sit in chairs all day long. So I think it's important to get hip extension when you're doing your back extension. And what muscle does hip extension? It's the gluteus maximus.
Absolutely, the prime mover.
Yeah, exactly. Yeah. And it's also responsible for external rotation. And when you look at hip extension, so bringing your thigh backwards with respect to your pelvis and your trunk, you can get more hip extension with external rotation when you're just looking at the joint. So I think a lot of people's experience with squeezing the butt in their back bends was a sensation of pain or tightness in their lower back, and yoga teachers would say, okay, well, don't squeeze your butt to help create more space in your lower back or reduce the pain. However, if you look at the attachments of the gluteus maximus, it doesn't cross over the lower vertebrae, the vertebrae of your lumbar spine. It's at the top of the pelvis,
yep,
and then to the femur, hence its action of hip extension. So in that experience of squeezing the butt, creating crunchiness or tightness in the back, perhaps that was more of an issue of the student using more of their lower back muscles when they thought they were using their gluteal muscles.
Yeah, yeah.
And that's something that I'm been interested in lately, is a coordination issue. I think a lot of times we think, oh, my abs aren't strong enough, or my glutes aren't strong, or it's too tight, whereas we might not be able to achieve a movement with as much freedom, not because of strength or flexibility, but of coordination, of a nervous system thing. So yeah, I think you should use your glutes when you're doing composite back bends, unless, of course, you're trying to just extend your spine.
Just to isolate.
Yeah.
I thank you for that. I had never heard the term composite movement before. That's a great one. Erin is in the midst of physical therapy school. How far along are you?
I'm halfway.
Halfway? You've been doing
there.
it for so many years. Wow.
Living on a prayer.
Living on a prayer. But that's incredible. And so thank you for offering your perspective from where you are currently halfway through physical therapy school as well. Talking the tailbone, do you think the issue is the concern is just about going too far into a posterior tilt? I mean, do you think that's all that is about?
I think that it has a lot to do with doing it too much, maybe, excessively, and it's also specific to the student. And I think that one of the things that you're great about when you teach class and you're cueing that pelvic movement is you are super specific to the students that you're speaking to.
Me? Oh, thank you.
I know, right? So it's great. I mean, if you see somebody that has super crazy anterior tilt, then of course then it would be functional cueing to have them tuck their tailbone, and taking the time to explain it to somebody that might not even know where or what their tailbone is and what do you mean by tucking it. So it's not just a matter of it possibly being too much of a general cue, but also does the person know what in the world you're talking about?
It's almost it's too ambiguous. Like what is that? Or like, and this type of language is less common in the Bikram series typically, but using this sort of like esoteric type of language, like drawing your tailbone toward the floor, things like that. You're like, what? Mm-hmm. You can't really move the tailbone toward the floor. I mean, you can tilt it forward, you can tilt it, but you can't really like draw it to the floor. I don't know.
Mm-hmm. Yeah. And I don't know if you talk about scapulohumeral rhythm. When you talk about lumbopelvic rhythm, it's breaking down the composite movement of a back bend versus a forward bend. So that, yeah, it's the context of where you're asking somebody to tuck their tailbone. If it's just in standing, then you're kind of just talking about a posterior or anterior pelvic tilt. But when you add it into a back bend or a forward bend, then it gets a little bit more complicated and fun.
And fun. We've pondered the flow of blood through the heart and the different components of the heart, how and when they contribute to that full lub-dub pumping action. I was curious about why the atria even exist. Like, why are they, like, in my head the atria are simply like a staging ground. They're just kind of like, they preload the blood, and then for the ventricular contraction to really push that blood all the way through to the extremities, to the depths of the vascular system. And something I haven't mentioned yet is that I showed you the thickness of the ventricular muscle layer, and it's much thinner in the atrial portion of the heart, because the ventricular portion those cavities are greater in volume than the atrial, and they have a thicker muscle wall because they need that explosive effort to push the blood all the way through the vessels. But then what is the purpose of the atria? Like, what are they doing? Why are they there? Everything, we've marveled at the complexity of, like, the scapula, for instance, and, like, how every little groove, every little divot has a purpose, you know, and it's like when you fit it all into the musculoskeletal system, it's like, wow, it's so efficient. Every surface of that plays a very particular role for a particular reason. Why do we have atria, though?
Yeah, and it was so, I was totally like, oh my gosh, why do we? This is so interesting. And it got me to think about the evolution of the heart, which I know you like to talk about. And the first thing that I thought of was backflow, right? Like, what would happen if you didn't have anything, kind of a barrier? And we had to look at, does the superior vena cava, for example, have a valve to prevent backflow?
Right. Superior vena cava or the pulmonary artery.
Or the pulmonary artery, and I think there's a carotid sinus that has an opening in there too. So I think there's 3 openings into at least the left atria, but I don't think any of them have valves to them.
Okay.
But that's right. We talked about how there are some pectinate muscle fibers that help to prevent the backflow there, but it's not like the semilunar valve or the tricuspid valve, that heavy duty of a function. So I thought of that backflow issue, but then I also thought of the electrophysiology of the heart. So you've got cardiophysiology, the muscular pumping action, and the electrophysiology, which is separate and distinct, and what makes the heart unique, and that it can contract on its own without the impulses from the nervous system and the brain. And that is housed in the atria. The pacemaker of the heart is housed in the atria. Yeah. So I was kind of thinking about that and how that makes it different from the ventricles. And then I did a little bit of dabbling in the evolution of the heart from fish to mammals, and found that it actually evolved from atria to 2 atria to 1 ventricle, and then into the 4-chambered heart. So it seems like it developed from having 1 atrium to 1 ventricle, and then dividing it vertically that way. Yeah. So we can map out our human evolution based on, our assumptions of from where we came, which was ultimately fish. But you're saying that fish hearts currently today have 2 atria and 1 ventricle. Is that correct? I think so. Yeah. Very cool. And you were telling me there is an animal that has just a ventricle, right, and no atria, or did I get that incorrect? I think that might have been the like a ancient creature. I see. Model. Oh, those ancient creatures. Yes. You got to watch out for those. But then there's like lungfish. I don't know. This article went into quite a bit of depth on like a lungless salamander, and then this lungfish creature. So I don't know what's out there, really, to be honest with you. But it's a really interesting question. And I think that thinking about things in this way is not only creative and makes learning more fun with respect to anatomy, but I think it can also help things stick better. So now that we've had this conversation about, well, you know, why do we have an atria, and then contemplating what would happen if you didn't, you know, how much more likely are you to remember the 4 chambers of your heart and your valves and all that stuff?
When Erin and I go out for cocktails, this is all we talk about. I will never again mix up the flexure digitorum superficialis and the flexure digitorum profundus because I now have this association and this correlation. Cool. Well, thank you, Erin. I will hopefully get an interview with Gil Headley talking more about the heart and how it evolved. There was a really great Rudolf Steiner study back in the 1920s about the fetal development of the heart and how it was initially a tube and then it coiled into 4 chambers. It's very, very cool stuff. So thank you.
Thank you.